Okay, now what we've been doing, what we did on the last assignment, we graphed with input output. Now I want you to learn a different way to graph, and yes, you do need to learn it. This is a line. The line has a slope because there are 2 points here. The line is moving up, but it's also moving forward, okay? So let's say it's a ladder between, it moved from here to here, we'll say, from here to here, the vertical, we'll say it's 8 feet. And we'll say the horizontal distance across, from the bottom to where the ladder ends is, let's go 13 feet. That has a slope. The slope is rise over run. It's the vertical change, which is 8, over the horizontal change, which is 13. So the slope's 8/13. Okay, now, what you're going to learn about today is slope-intercept form. Graph the equations using the slope and the y-intercept. I don't want you doing input-output, okay? You need to listen here. This is actually a lot quicker than input-output. Okay, anytime I have a y over here by itself with x on the other side with a bunch of operations, but the y has to be by itself. Y and x opposite, y by itself, x has some operations. It's what we call slope y-intercept form. Now, there's 2 parts of this. There's slope and there's y-intercept. In algebra, slope is the letter M, and y-intercept, don't ask me why, it's called the B. Okay, B stands for the beginning, and it's always mx. Whatever x being multiplied by is your M, and then whatever's being added or subtracted is your B. Okay, it's mx plus or minus b. In this case, plus. So my slope is 1/4, okay? So 1 over 4. I always want my slope to be a fraction, actually. And the y-intercept then, it says -3, so that's like plus -3. So the y-intercept is -3. Now, with your y-intercept, you always want to put a comma before it, and you're always going to put 0, okay? And that's a coordinate you graph. You graph this first. So x being 0 means you stay in the middle and you go down 1, 2, 3. That's your y-intercept. Now a slope is rise over run. It's vertical over horizontal. So since the 1's positive, it will go up. And the 4 is positive, so it goes to the right. Okay? So from this beginning point, what you do is you go up 1 unit, you go right 4 units. Do it again. You go up 1 unit, right 4 units. Okay? And you take your ruler and graph this. You're not going to need a calculator when doing this. You won't. Okay? And that's my line. There it is. And I'm going to write the equation. Y equals 1/4 x minus 3. It is a much quicker, more efficient way. So again, this is in slope-intercept form. Slope-int. So there's the slope and there's the y-intercept. You can abbreviate if you want to. Now the slope is m, the y-intercept is b. So the m is the x multiplier, and then the b is what is being added, okay? So the slope's -4/5. That's good. I want my slope to be a fraction because it wants to be in ratio form. And the y-intercept is 6, and then I put a comma with a 0 because that's a coordinate point. So I stay in the middle because it's x, y. x being 0 means I stay in the middle. I go up 1, 2, 3, 4, 5, 6. Now this makes sense. The logic behind it is that if x is 0, anything times 0 is 0 plus 6 is 6. And that's why that always is that way. And then this time it's rise over run, okay? Now since the 4 is negative, you go down instead of up. And the 5 is positive, so we'll go to the right, okay? Generally you always go to the right. Nothing really goes to the left. The bottom's kind of always going to be positive for us. So from this point, 0, 6, I go down 5 units and right 5, down 4, 1, 2, 3, 4, and right 1, 2, 3, 4, 5. Okay. Now I would want to do it again, but 1, 2, 3, 4, 1, 2, 3, 4. I could put it right here, I guess. Okay. If you run out of room, 2 points will work. So you take your ruler or straight edge, make a graph. It's continuous. Put arrows on both. And on this line is where the equation y equals negative 4/5 x plus 6 lies. Okay. So for example, let's look at this point. So at this point here, don't do this, just watch. So at this point, -1, -2, -3, -4. Okay. Nope, hold that thought. Never mind. Example 3. Okay, once again, the y is by itself, but the x has operations going on with it, so that makes it slope-intercept form. Okay, so we have the slope and the y-intercept. Okay, so my slope is m and the y-intercept's b. So we have m and b. M is the x multiplier. Now your slope is -8. Now that's an integer, but we can make that into a fraction by putting a 1 with the denominator, which we're going to want to. And the y-intercept's 2. Okay? And then there's always a 0 because x at the y-intercept, the x is 0. So I stay in the middle. And I go up 1, 2, and that's where 0, 2 is at. Okay. Then from that point, it's rise over run. So this will be a vertical down, and then 1 to the right. So from this point, I go 8 units down. 1, 2, 3, 4, 5, 6, 7, 8, and then 1 to the right. And I can't do it again because I can't go down. I'll be way on the other graph. So I'm just going to do these two. So if you run out of room, it's not a big deal. The line looks like it's supposed to. Okay, it's just kind of nice to have more than 2 points so they line up. Now, that line's very steep. Now, the reason that's steep is because -8, those whole numbers are steeper slopes than the fractions. So that's how that works. So somewhere on here, y equals -8x plus 2. That's anywhere on that line. Any x coordinate on the line can be multiplied by -8 and have a 2 added, and it's going to be exactly where the y coordinate's at. Okay, example 4, y equals 6x. Again, you got the y by itself with the x having some operations. Anytime that happens, that's going to be slope int form, okay? So I'm going to start abbreviating slope and y-intercept. Slope is m, y-intercept is b. Okay, so my slope is the x multiplier of 6. Now you're like, well, what so 6, that's an integer, so we put a 1 under it. Now you're like, well, what about the y-intercept? Well, there is a y-intercept. You can add a 0 to it. Okay, so the y-intercept 0, 0. So the y-intercept 0, 0 is what's called the origin. Okay, it's at the middle of the graph, origin. And you can write that word if you don't. You can write 0, 0 or origin, doesn't matter. Then from the origin, then 6 is positive, so that will be up. and 1. It's vertical, it's rise over run. Okay, you got to get that right. If you do the horizontal over the vertical, that's wrong. Okay. So 1, 2, 3, 4, 5, 6 over 1. And I can't really do it again, so I make that line. Okay, and then on that line, just write the equation y equals 6x. Okay, example 5. Okay, again, you got the y equals, and then x has some operations going on with it with some values. So again, that's always in slope-intercept form. Okay, so slope, y-intercept. So my slope is m, and that's b. So slope is always mx, so m would be 5/6, plus negative, and that would be b. So always mx plus b, and b would be -3 with a 0. Okay, so xy, so if x is 0, you stay there, go down 1, 2, 3. Then from there, 5's positive, so it's a rise of 5. And 6 to the right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I can go up 5, but I'm not going to be able to go 6 to the right. So I can just go with those 2 points. Okay, now starting on the next problem, I would like you to actually trace your path before you actually do that, because you're going to see why here. Okay, so you got another slope-intercept form equation with x and y. Y is by itself. X has an operation of 5 times, and 10 being added. So you got slope and y-intercept. So the slope's m, and the y-intercept is b. So mx, b. So slope's 5. If it's an integer, you put a 1 underneath it, and the y-intercept is positive 10. Okay, so 10, and then it's always a coordinate, 0. Okay, so if x is 0, we're in the middle, but if I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and you're like, well, I'll just go there. Yeah, but then you got to go up 5. How are you going to do that? So let's count by 2s. So 2, 4, 6, 8, 10. Now I can have the y be 2s and the x still be 1s. That's fine. I'm allowed to do that. So I go up 5 and write 1, because 5 is positive, I go up. But I need to count by 2s when I do my vertical. So 2, 4, and then 5, and then 1 to the right. Now I can still have the x be worth 1s while the y is worth 2. That's fine. That's allowed. They don't have to be the units don't have to be the same for each axis. Okay, so we have y equals 5x plus 10 anywhere on that line. Okay, next one. This gets really repetitive. Okay, again, the y by itself, x has an operator of 3/5 timesing it, and then minus 2. So that's a slope-intercept form. And slope, y-intercept. So slope is m, y-intercept is b. So the slope is m, and then the y-intercept is b. Make that plus negative because it's mx plus b, so it kind of makes more sense if there's a plus. Okay, so my slope is 3/5. That's already a fraction. It's not an integer. And then -2 would be my y-intercept, with, of course, x being 0. So I stay in the middle, go down 2. That's 0, -2. Then 3 is positive, so I go up 3 and right 5. So it's vertical over horizontal, rise over run. Okay, rise, run. So I go up 1, 2, 3, 1, 2, 3, 4, 5. Can I do it again? 1, 2, 3, 1, 2, 3. Nope, off the graph. So all right. So I'm going to write the equation. Y equals 3/5 x minus 2, or plus -2, don't matter, same thing. Okay, example 8, y equals -5x plus 7. So again, you got the y by itself with the x operator, so that's slope int form. Okay, so you got your slope and your y-intercept. It's always the y-intercept. It will always be on this line here. That's the y. Slope would be then m and b. So -5 is my slope, and to make that's an integer, so put a 1 under it, and then the y-intercept is +7. Okay, so, or just put 7 with 0. Okay, so 0, 7, 1, 2, 3, 4, 5, 6, 7. And then I go down to the right, okay? I'm going down because we have a negative from here. So 1, 2, 3, 4, 5, right 1. I could do it again. 1, 2, 3, 4, 5, right 1, and 3 points is good enough. It's going to be a very steep line because anytime my slope is an integer, it ends up being steeper than if it was a fraction. Okay, so y equals -5x plus 7. All right, and then the last two. Again, the y, x has operators with it, so with it, and then so that's slope-intercept form. Okay, so slope, that's m. And the y-intercept is b, okay? So this is mx plus b, so m is -3, that's an integer, so that's over 1. And the y-intercept then is +6, with 0 as the x-coordinate. Y-intercept always has 0 in the x as the x-coordinate, because if you took -3 times 0 plus 6, you get 6. Okay, so 0, 6. So 1, 2, 3, 4, 5, 6. Okay, and then I have a negative, so I go down 3 and 1 to the right. So down 1, 2, 3, 1 to the right. Do it again. 1, 2, 3, down to the right. And that basically happens throughout the whole line. But I just need 3 points. Okay, arrows on both ends. So now I have that equation is y equals -3x plus 6. Okay, and then finally, once again, the y is by itself. X got some operations going on the other side of the equation, so that is in slope-intercept form. All right, so slope y-int. Slope is m, y-intercept is b. Okay, so m and b. So m -1/2. Good, it's a fraction, and then 4, 0. Okay, so remember the first number is an x, but you're in the middle, so 1, 2, 3, 4. So 0, 4. And then I have a negative. The negative's with the 1, not with the 2. So down and to the right. The bottom, the denominator, when I do slope-intercept form on a graph, the bottom's positive. It'll be to the right. So I go down 1, right 2. Down 1, right 2. You don't need to label the subsequent points. That's fine. By the way, if I made you label them, you'd be at 2, that'd be 2, 3, and this would be 3, 2. Because you're at 3 on the x, 2 on the y. Okay, and that's the equation. Y equals -1/2 x plus 4. All right, that's all I have to say on that. It's pretty boring, but it is something we will use as time goes on.